Hello everyone, I am Nilin Masara binti Hamzah and I will present and explain the calculation for this project. So first we do the calculation for the impedance, where calculation for impedance is by using the formula for each component, which for example the capacitors and inductor, and then the total impedance calculates by doing the series part first, and then we proceed with the parallel part. Next, to find its total current, the Ohm's law formula has been used where the voltage will be divided with the total impedance here. You can see it here. Then after getting the results for the total current, we can now calculate the current for each impedance, where in this experiment, for current of R1, it has the same value with I total as it is in series connection with the voltage source. So it has the same current value. And then while the other impedance, we need to calculate it, especially for current, by using the current divider rule formula. After doing the calculation, here we can see the calculation by using current divider rule for each impedance R2, R3, C1, C2, and L1. After doing the calculation, it can be observed that the current for R2 and C1 has the same value, while the current for R3, C2, and L1 has the same value, as all of it are in a series connection. After doing the calculation for current, we can now do calculation for voltage. So for this voltage, to calculate it, here you can see, we use the Ohm's law formula. We apply the Ohm's law to calculate the voltage. As you can see here, this is the total current that we get before for R1, and we multiply it by the impedance that we get before, the first step that we do just now. And then after getting all the result of current and voltage, we can now proceed with the calculation of phase difference. To see with the purpose to see which one is leading and which one is lagging for the voltage and current of each impedance. After doing all the calculation, now it's time for the simulation. And for the calculation and simulation part, it shows that it has the same value for both parts. So it is proven that the calculation that we did is correct. And then while doing the simulation, the important thing that we need to take care of is when we are in this project, we are using the single frequency SC for to see their current and voltage values. So to get the precise answer and the precise value in simulation, we have to change the SC analysis magnitude of the power source. And then for this SC analysis magnitude, it has a calculation in it where we divided the current for the first part with the current from the calculation with the current from the simulation, where we not yet change its SC analysis magnitude, and then we will get the value. As you can see here, we get the value 110 for its SC analysis magnitude. I think that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Okey, nama saya Muhammad Fakrul Razi. Dalam assignment kumpulan grup saya akan membentangkan bahagian multisim. Ini adalah multisim yang saya telah ni. Purpose untuk multisim yang kami buat ni kan adalah untuk menentukan bahawa kaitan mengenai antara simulasi dengan calculation, sebab kita tahu calculation, yes, kita boleh perform. Ada calculation, oh okay, gini-gini. Tapi bila kita masuk simulation, dia akan berbeza. So ini adalah simulasi yang saya telah sediakan. Okay, untuk nilai-nilai ni kan, kita orang satu grup mengatakan satu pakat supaya tidak menggunakan nilai pada di sini, dan kami hanya menggunakan nilai untuk kami akan gunakan nilai ini. Bahagian single axis frequency saya akan ubah kepada 10K lah, sebab kita punya ni 10 kilo. Lepas tu kita punya output dia. Okey, lepas tu kita akan run. Okey, ini adalah nilai. Maaf ya, sebab ni adalah real imaginary. Kita nak pakai dalam bentuk magnitude dengan phase. So saya akan tukar. Okey, ini adalah untuk nilai phase dengan magnitude, untuk nilai current dengan voltage. Okey. Lepas tu kita akan masuk bahagian waveform pula untuk resistor. Okey. Ini adalah waveform untuk resistor kan. Ini adalah bukan contoh lah, ini kiranya simulasi yang saya telah run. Okey, ini adalah untuk ni yang pertama. Okey, saya buka satu dulu. Ini adalah simulasi yang pertama bahagian ni. Untuk R3. Ini dia punya bentuk dia. Okey, kita akan masuk kepada waveform untuk simulation yang ni, R2 punya resistor. Bentuk dia sama juga sine wave, cuma dia punya ni antara bentuk dia tu tidak setepat macam sine wave, tapi ada ciri-ciri sine wave lah. Sama juga yang ini. Ini lebih uniform lah, sebab ini adalah berada di awal-awal. Kiranya dia hanyalah satu tunggal resistor saja. Macam R2, R3, R2 dia gabung dengan kapasitor kan. Satu litar ni dia gabung dengan kapasitor. Tapi untuk R3 dia agak lurus, sebab kita tahu induktor itu dia menjadikan AC kan, supaya tidak mengubah arah. Kiranya dia akan jadi ibarat macam litar itu ibarat macam DC bila dah melalui induktor tersebut. Okey, saya settle bahagian waveform. Saya akan masuk bahagian kapasitor. Okey, ini adalah litar untuk kapasitor kami. Dan juga ini adalah yes, this one is bentuk untuk kapasitor 3 C3. So as you can see, yep, bentuk dia sama juga, masih juga sine waveform. Sebentar ya. Yes, and then ini adalah kapasitor kedua, sama juga. Maaf ya, lebih uniform lah. Lepas tu ini adalah untuk inductance. Yep. Kalau kita tengok inductance dengan kapasitor inductor ni akan lag. Kiranya akan ke belakang, lambat. Bila lag dia akan lambat daripada segi degree dia punya phase. Okay, itu saja daripada saya.
Hi, my name is Anisaja B20TV and my ID is B21014. So here I want to discuss about the result of the calculation and simulation and our finding of this experiment for part A and part B. So here is the result of the calculation and simulation part for VR1, 93.04 and 46.82 degree. For VR2, 17.88 volt and 67.24 degree. For VR3, 15.2 volt and 34.97 degree. VC1, 0.14 volt and negative 22.76 degree. For VC2, 0.12 volt and negative 55.03 degree. And VL1, 9.55 volt and 124.97 degree. For the simulation part, we got VR1, 110 and 50 degree. VR2, 17.88540 volt and 66.78361 degree. For VR3, 15.19888 volt and 34.5138 degree. For VC1, 142.32302 millivolt and negative 22.76045 degree. For VC2, 120.94500 millivolt and negative 55.03023 degree. VL1, 9.55 volt and 124.97 degree. For the current of the calculation, IR1 23.26 milliamp and 46.82 degree, IR2 8.94 milliamp and 67.24 degree, IR3 15.2 milliamp and 34.97 degree, IC1 8.94 milliamp and 67.24 degree, IC2 15.2 milliamp and 34.97 degree, and IL1 15.2 milliamp and 34.97 degree. For the simulation part, IR1 we got 23.25499 milliamp and 46.81725 degree. IR2 8.94242 milliamp and 67.23955 degree. IR3 15.19840 milliamp and 34.96977 degree. IC1 8.94242 milliamp and 67.23955 degree, and IC2 15.19840 milliamp and 34.96922. IL1 15.19840 milliamp and 34.96977 degree. So here we can see for IR2 and IC1 we got the same value, because as we know in the series circuit the current is the same, and also for the IR3, IC2 and IL1 also got the same current. Throughout this experiment, a lot of discussion was made about the RLC circuit. And RLC circuit is an electrical that contained with a resistor which R, an inductor L, and also a capacitor C. This RLC circuit can be connected either in series or in parallel circuit. And now we know what is actually RLC circuit, and this experiment helped us to know more about an RLC circuit, such as what is the use of the circuit, and it also introduced us with the formula that we have to use and to make a calculation of the circuit. It actually has its own formula between the resistor, inductor, and also the capacitor respectively. Before we start to calculate the voltage drop or current flowing through each component, or I know it as impedance. In RLC series circuit, when the AC voltage supply is applied, the resulting current I flow through each component will remain the same. Thus, the voltage drop across each component will be for resistor R, VR equal to IR in phase with the current. For voltage across inductance, L, VL equal to ISL, it's lead the current by the angle of 90 degree. And for the capacitor C, it lags the current by 90 degree. The total voltage across the circuit is actually not just the algebraic sum of the voltage drop across each component, but it was the vector sum. For the parallel RLC circuit, the resistor, inductor, and also the capacitor will be connected in parallel to the voltage supply. It was actually contrary to the RLC series circuit. The voltage across each component will remain the same, but the current will be divided. The total current of the circuit is not equal to the mathematical sum of the current flowing through each component, but it was equal to the vector sum of all the current. The current through each element can be found by using the Kirchhoff law, which deals with the conservation of charge leaving and entering a node. For the simulation part, through this experiment, also a lot of discussion was made to build or design the circuit. With this experiment, we can explore more about the function of the multisim, and we know how to display or got the exact value of the voltage drop and also the current flow through each component with the angle in analysis and simulation part. We also know how to make the value more precisely by adjusting the AC analysis magnitude at AC source. We also use the AC voltage rather than AC power because with AC voltage we can set the voltage peak on it, so it's easy for us to use. We also use the current clamp to get the waveform of the voltage and also the waveform of the current across each component. If we just straight use the general oscilloscope, we only can get the voltage, so it helps us to know the function of the current clamp in the simulation.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Fariduddin bin Muhammad Ilyas, ID TG12047. Today I will talk about the conclusion for our experiment for subject circuit analysis. So in conclusion, we learn how to use the independent circuit to find the voltage and the current for RLC circuit. We also learn how to find the resonance frequency for the RLC circuit. In order to be a design for this circuit, for this experiment, there was a lot of discussion that we made. With this experiment, we can learn more about the multisim function. In the analyze the simulation part, we know how to display or get the value, the voltage drop, and the current flow through each component with the angle. We also know how to fine-tune the value by the adjusting the magnitude of the AC analysis, and also we use AC voltage rather than AC power because we can set the voltage peak on the AC voltage, make it easier for us to use. Also, the current clamp is also used to obtain the voltage waveform as well as the current waveform across each component. Thank you.